Hello friends, welcome to YouTube channel Electrical Design Engineering. Today is our ninth lecture of our free course Design of Transmission Lines and Distribution Lines. Before starting the lecture, I have a small request, that is to subscribe the channel, like and share the videos on your social media profiles. You can also join our WhatsApp group. The link of that group is given in the description. In previous lecture, we have studied about letter of intent, bill of quantity and estimation, survey of power lines, permissions needed for transmission and distribution lines, load, connected load, maximum demand, demand factor, and diversity factor. SLD preparation, that is single line diagram or a one line diagram. We have also prepared a single line diagram using Autocad and Etap. Nominal voltage and rated voltage, calculating phase-to-phase clearance of transmission lines, phase to ground vertical clearance of transmission lines, phase to ground horizontal clearance of transmission lines. In today's lecture, we will see phase to vertical clearance from highest point of building, clearance between transmission lines crossing each other, height of towers or poles for various power lines, structural drawings, calculating the weight of the steel. First of all, one of the question which my viewer have asked is, thanks sir, good practical explanation, how to find calculate span, which data use for finding phase to phase distance. These are actually two questions. One question is how to find span or how to calculate a span, and second question is what are the data needed for calculating the phase to phase distance. In the previous lecture, we have given a formula, we have taught you a formula as per IS 5613 part 1 section 1 1985. As per the formula, D, that is the phase to phase distance, equals 500 plus 18u plus L square divided by 50, where as per this formula the phase to phase distance between lines depends on two variables. One variable is u and another is L. U is the line to line voltage in kilovolt and L is the span in meter, that is the span of a transmission line. So for finding the phase to phase distance of any transmission line, we should know what is the line to line voltage of that transmission line and what is the span of the transmission line. The first part of the question, how to find and calculate the span, will be taken when we deliver a lecture on the span of transmission lines. At that point, I will explain this, how to calculate the span, how you can find the span of a transmission line. Now, we will go to start today's lecture. This is the building or any structure, and this is the highest point of the structure. This is the power line passing above the structure or a building, and this is the vertical clearance between power line and the building. What should be the vertical clearance? What should be the minimum vertical clearance between the highest point of the building and the power line passing above the structure, so that the power line does not affect the structure or a building or a person is living in the building? For that, we have given this chart you. This is the voltage line, that is the line to line voltage, and this is the distance in meters, that is distance from highest point of the building in meters. For LT lines it is 2.5 meters, and for 11 kV line it is 3.6 meters, and for 33 kV it is 3.6 meters, and for 66 kV line it is 4 meters. Similarly, for 132 kV line it is 4.6 meters, and for 220 kV line it is 5.5 meters, and for 400 meters, for 400 kV line it is 7.3 meters, and for 765 kV line it is 11.9 meters. Now the question arises, how you can calculate this distance? Generally, I can give a thumb rule to you. The thumb rule is D equals 3.7 plus 0.3 for every additional kV above 33 kV. For every additional 33 kV, you have to add 0.3 for every additional kV above 33 kV. That means you can understand this thing by calculating the vertical distance of a 400 kV line. We can calculate the distance of a 400 kV line from the highest point of the building using this formula. From this example, you can know how we can calculate the vertical distance of any transmission line above 33 kV line. For 400 kV line, D equals 3.7. 3.7 is of formula plus 0.3 into 400, that is the line to line voltage, minus 33 divided by 33. It becomes D equals 3.7 plus 0.3 into 11.12. That equals D equals 3.7 plus 3.34, which equals 7.04 meters. You can see here for 400 kV line the vertical distance is 7.3 meters, and here it is 7.04. Almost same height is coming from using this formula or from chart. In this way you can calculate for vertical distance for any transmission line above 33 kV using this formula. At various places you are seeing the various transmission lines are crossing each other. Like this, you can see here one of the transmission line is going in this direction and another transmission line is going in this direction. They are crossing each other at this point. What should be the vertical distance between these transmission lines, or what should be the distance between these two transmission lines at the point of crossing, so that they do not affect the power transmission of each other line? For that I am giving you this chart. You can take the screenshot of this chart. Here the lines are LT line 11 kV, 33 kV, 66 kV, 132 kV up to 765 kV. Similarly from here, from LT line to 765 kV line. If two LT lines are crossing each other, then select this column, that is the LT line, and from here LT line it is 2.5 meters. Similarly, suppose 60 kV line and 400 kV line is crossing each other. This is the 66 kV line, and we can go for here it is 400 kV column, 400 kV line column, that is 5.5 meters. Similarly for 220 kV, we can go, suppose 220 kV line and 33 kV line is crossing. From 220 and 33 here it is 4.5 meters. In this way you can find the clearance between transmission lines crossing each other up to 765 kV line. You can see, you know that the transmission lines are supported by the poles, up to 33 kV, and above 33 kV, towers are used to support the conductors or transmission lines. What will be the height of these poles or towers for different power lines? This is the pole structure. This is a steel tubular pole. Generally, it is used. These type of poles are used up to 33 kV. And this is the tower structure. And above 33 kV, towers are used. For LT lines, steel tubular poles, 8-meter poles are used. For 11 kV line, 9-meter poles are used. And for 33 kV line, 11 meters of pole are used. These are generally poles used. But when there is a crossing of roads, when the road crossing, then we can use higher sides. For LT lines, we can use 9-meter. For 11 kV line, we can use 11-meter. And for 33 kV line, we can use 13-meter pole. For voltage above 33 kV, towers are used. For 66 kV line, 16-meter tower is used. The tower height is 16 meters. For 132 kV line, the tower height is 21 meters. For 220 kV line, the tower height is 32 meters. And for 400 kV line, the height of tower is 45 meters. And for 765 kV line, the tower height is 63 meters. Now, we will talk about the structure drawings. First of all, we should know what the structure drawing means. A structure drawing contains details describing how a structure should be built. That means a structure drawing contains details about how the structure should be built. What is the information in the structure drawing? That contains information about height of structure, arrangement of various structural elements like V-crosses, clamps, insulators, bill of material, how many clamps are used, how many insulators are used, how many poles are used, or how many towers are used, what is the angle deviation of the tower. All the things are mentioned in the structure drawing. Weight of the structure, what is the total weight of the structure, what is the unit weight of the structure. All the things are mentioned in the structure drawing. I can show you some structure drawings where you can see what are the information contained in the structure drawings and how they look like. This is the structure drawing, G8 drawing of LT line single phase structure for angular location on 8-meter steel tubular pole. You can see this is the structure drawing. Structure drawing generally looks like this. This is the height of tower, the height of the pole, 8,000 mm, that is 8 meters. And this is the clamp details. This is the clamp full detail is given here. What is the hole size? What is the total length of the clamp? All the information is given here. This is the bill of material. All the information is given. How many clamps are used? How many insulators are used? What is the weight of the unit clamp? What is the total weight of the clamps? All the things are mentioned here. What is the size of the clamp? This is the another drawing, structure drawing of a line. This line is a straight line. This is the V cross details. Here the detail length of V cross is 7,200 mm. This V cross is 7,600 mm. That is 7.6 meters. And this V cross is 6,800 mm. And the structure, the beach, the middle structure is of 1,200 mm. That is 1,200 mm. This is the height of tower is mentioned here. The height of each section is also given here. This is the another structure drawing. Here This is the structure drawing at angle deviation. You can say this is the insulator, two insulators. The angle deviation is 30 degree. That means when line is coming from this side, it does not go straightly this side. It is diverting 30 degree to this side. All the information is here also given. Here the V cross width is given, the V cross length is given, that is 7200 mm. Now the clamps are made up of GI steel. Similarly, the towers are of a transmission line are made up of steel. How you can calculate the weight of the steel? Now we will see the how to calculate weight of the steel. Weight of steel, that is the mass of the steel, equals density into volume. The density of steel is 7850 kgs per meter cube. Mass of steel equals density is 7850, so this 7850 into volume, volume is in meter cube, into volume. Suppose we have a flat, this is the flat MS flat of size 40 into 5 mm of length 1 meter. We have to calculate the weight of this flat. Width is 40 mm, that is 0.04 meters. Thickness is 5 mm, that is 0.005 meters. And length of the flat is 1 meter. Area is equal to width into thickness, that is width is this and thickness is this. On multiplying this, the area of cross section of the flat is found. It becomes 0.04 into 0.05. Width is 0.04 here you can see, and thickness is 0.05 you can see here. It becomes 0.0002 meter square. Volume of steel is called area into length. Area is 0.0002 into length is of 1 meter into 1, that is 0.002 meter cube. Now putting the value of this volume in this equation, we can find the mass of the steel. Mass of steel is equals 7850 into volume equals 7850 into volume is 0.002. It becomes 1.57 kgs. So the weight of the flat of this cross section area is 1.57 kgs. Now weight of the steel flat is 40 into 5 mm size is 1.57 kgs per meter. Similarly, weight of the flat for 50 into 6 mm is 2.37, and weight of flat 100 into 6 is 4.71. MS channel ISMC 75 into 40 into 6, this is the dimension of the channel. The weight per meter is 6.74, and for MS channel ISMC 100 into 50 into 6, this is the dimension is 100 into 50 into 6. The weight of the steel is per meter is 8.85 meter 5 kgs. For an angle ISA 50 into 50 into 6 is 4.43. Now the question arises, what does the ISMC stands, or what does ISA stands? ISMC is called means Indian Standard Medium Channel. This is the standard medium channel. ISA is Indian Standard Angle. And then density of the mild steel is 7850 kgs per meter cube. I have given this weight of these flat or channels because these are the flat generally used in our structures in distribution system. You can calculate generally from here. If the size, if your channel is 75 into 40 into 6, and per meter the weight of the steel of this channel is 6.74 kgs. This is the flat. This is the width of the flat, and this is the height of the flat. Flat looks like this, and this is the channel. Suppose we have a channel MS channel ISMC 100 into 50 into 6. That means it is width, that is this portion, or this portion which is called the depth of the channel is 100, and 50, that is this portion that is called the flange is 50, and 6 mm, that is the thickness of the channel is 6 mm, that is called the web is 6 mm. You have seen this side, the channel picture. This is the angle of ISA 50 into 6. 50 means this is the height of the 50, or width is 50, and the thickness is 6 mm. The channel angle looks like this. Pole, we have generally using poles: 8-meter pole, 9-meter pole, 11-meter pole, 13-meter pole. What is the weight of these poles? The weight of pole of 8-meter is 119 kgs, that is of specification 410 SP15. Similarly, for 9-meter pole of specification 410 SP33 is 154 kgs. For SP57 11 kV pole, the weight is 750 kgs, and for 13-meter pole, it is 343 kgs.